Array of Engineers has developed an automated test controller that conducts automated verification procedures on electronic devices, hardware, and systems. The ATC is a rack-mountable unit that is designed for desktop testing applications for industries such as medical and defense. Based on the Xilinx UltraScale system-on-chip, the ATC is a highly versatile analog and digital data acquisition model. While the ATC is a viable product, customers have expressed interest in a more portable version with similar functionality. This portable version of the ATC will allow Array of Engineers customers to easily field test without having to transport the equipment into the office. Array of Engineers has requested the creation of a newer and more portable version of the ATC that, while having some reduced functionality, would add certain other features. The ATC Lite was developed with a ruggedized enclosure to ensure drop protection and is sealed from dust and water. The new design is less than 2/3 of the original automated test controller. An accompanying graphical user interface was also created that will allow users to easily verify incoming and outgoing data. Our team consisted of Team Captain Carmen Von Eyre, Benjamin Brown, Ian McDowell, Donald Peterson, Taylor Rieger, and Dominic Smith. While there are nearly 150 written specifications, the primary features of the ATC Lite was the ability to communicate with various communication protocols. A few of these protocols that were required to be integrated into the ATC Lite were communication with general purpose inputs and outputs, serial communication, controller area network and local interconnect network that are used in vehicles, Ethernet, USB, military standard 1553, inter-integrated circuit, and serial peripheral interface. For the most part, all of our specifications on screen were met. While conflicting issues required a few to be adjusted, each case was discussed with the sponsor to determine the correct course of action. A couple of challenges that our team overcame were the orientation of circular connectors on the front of the enclosure. If not oriented correctly, the ribbon cable would not properly connect to the breakout board. We also underestimated the time and effort required for firmware development and testing. The primary initial challenge, though, was concerning electronic part shortages. We had to redesign certain circuits based on availability, as well as select parts that would ensure part availability for future builds. Thank you for taking the time to watch our presentation. We hope that you have enjoyed learning about the ATC Lite.